So, hello students, I am Dr. Shikha Pandey, Associate Professor from Institute of Aeronautical Engineering. Today in this Hall Container System module, I will again deal with the analysis of collection system. So, I will deal the third part of this topic, that is Hall Container System. In Hall Container System, this is the third part. First of all, first we'll calculated the whole operation, how this Hall Container System operation will be done. And next, I discussed about the layout of the collection, how we make a layout for an apartment or for an area where this collection method should be done. Now we are going to discuss about the analysis of collection system. Like we will discuss which method is better and with respect to the cost effective, with respect to the sanitary condition, which method will be best, like Hall Container System exchange mode method or stationary container mode method. So first of all, we will start with the problem statement. As I have already discussed about this Hall Container System, so today's class I'll just start with the problem statement. Like in this problem statement, one waste collector service provider is there. He wants to make a waste collection system in a city, for a city, but he has a fear like that which method he should adapt and which method is cost effective method. So in search of a cost effective method, the person is thinking that which we should adopt. This is a problem statement, like what he wants to do. A private solid waste collector wishes to locate MRF near a commercial site. So MRF location, their landfill location should be nearby to the commercial area, should be nearby to the commercial area, and he wish to locate this type of collection system. So the it should be nearby to the MRF site. Next point is that the collector would like to use a Hall container system, but fears that the Hall cost might be prohibitive. Means the cost should be more. So he has a fear like maybe the cost will be more. So what is the maximum distance? Our problem statement is that what is the maximum distance away from the commercial area that the MRF can be located, so that weekly cost of the Hall container system do not exceed those of the stationary container. So this is the problem statement. What is the maximum distance away from the commercial area that the MRF can be located, so that the weekly cost of the Hall container system do not exceed those of the stationary container? Means how much distance. There's a problem is like that, how much maximum distance that should be away from the commercial area that the MRF can be located, so that weekly cost, the total cost of the Hall container system do not exceed those of the stationary container. Means the weekly cost of the Hall container system will not exceed as compared to the stationary container. So he wants to make a maximum distance, how much maximum distance he has to cover for the commercial area that the MRF can be located, so that weekly cost of the Hall container system do not exceed those of the stationary container. So we will start this problem statement like this. Assume that one collector driven vehicle will be used in each system, and we have to assume it like that only one collector vehicle is there, and for the purpose of this example, assume the travel time T1 and T2 are included in the off-route factor. So the purpose of this example is that we have to assume that T1 and T2 are included in the off-route factor. During the off-route factor, T1 and T2 are located. So what in this problem statement we have to calculate how much will be the maximum distance away from the commercial area that the MRF can be located, so that weekly cost of the Hall container should not exceed those of the stationary container. So this is our problem statement. We have to calculate the maximum distance, and for this one we have to assume that the one collector driven vehicle will be used in each system. Means like one collector driven vehicle will be used, only one vehicle will be used, and for the purpose of this example, assume that the travel time T1 and T2 are included in the off-route factor. Two time is there, T1 and T2, and they are included in the off-route factor. So for the Hall container system, because these are the values that are being given, and we have to assume that for a Hall container system, quantity of the solid waste, how much solid waste is there, is 230 meter cube per week. Per week. Okay. Then the container size will be 6 meter cube per trip. 6 meter cube per trip. This is the size of the container. And the container utilization factor is equal to 0.67. 0.67 we have to consider. And the container pickup time is 0.33 hours per trip. Pickup time is 0.33 hours per trip. 0.33 hours per trip. And the haul time constant, that is A is equal to 0.22 hours per trip and B is equal to 0.014 hours per kilometer. So this A is the hours per trip and B is the distance, that is in kilometer in per hour. And the at site time is the 0.53 hours per trip and overhead cost is 28464 per week, and the operational cost will be 1000 rupees per hour of operation. So these are the given data for this haul container system. As we discussed, like this basic data we need to calculate the hauling of a operation, whole operation. So the quantity of waste generation is the 230 meter cube per week. In a week, 230 meter cube of solid waste has been generated, and there the container size is the 6 meter cube per trip, and the container utilization factor is 0.67. Container pickup time is 0.33 hours per trip, and the hauling constant time A is equal to 0.22 hours per trip. These are the important factor. B is equal to 0.14 hours per kilometer. So this A and B has been given, and their at site time they are utilizing in the at site, like on the site the time utilizing while hauling the container or picking up the container or for empty container. So for all these things the time is like for every trip per trip is 0.053 hours per trip is the time required. And the overhead cost means per week cost is 28,000 rupees. 28,000 rupees is a per week cost. 28,464 is a total cost for a week. And for 1 hour of operation, total cost is 1,000 rupees and per hour of operation. So these are the data that has been given for this haul container system. So next we'll calculate we'll discuss about the data that has been given for the stationary collection system. As this solid waste management has been confused whether he will go for this haul container system or a stationary container system, which one is better? In haul container system and stationary container system, which one is he has to adapt? Stationary container system, which method he has to adapt. So we'll compare. First we'll compare the given data in both of the systems. So it has been given like 230 meter cube per week. Same it is given in the first one also. Their container size is 6 meter cube per location, but all are same. Container utilization factor is also 0.67. Collection vehicle capacity is 23 meter cube per trip. Collection vehicle compaction ratio is 2, because this is a stationary compact container system. So this vehicle compaction ratio will be used, and container unloading time is 0.5 hours per trip. This time they have been that is a PC time, like they have utilizing for the unloading of the container. Haul time constant A is equal to 0.022 hours per trip and B is equal to 0.14 hours per kilometer. At site time what they have been spending is like 0.01 hours per trip at site. So for when we see the overhead cost is like 53,370 per week. 53,370 per week. Okay, and and for a 1 hour of operational cost is 1423 per hour of operation. So, and in this first one is the haul container system. Their per week overhead cost is 28,000 only, and operation cost is 1,000 rupees only. And just contrary to it, it has been more for this stationary collection system, like 53,000 rupees. 53,000 rupees is there. 53,000 rupees per week, and 1 hour cost is 1,423 per hour of the operation. So all values are same, but the cost is more in stationary container system. You can also see that this type of data. And now the average characteristics of the location, because location characteristics is much important, like how much distance the vehicle needs to reach at the MRF site. Vehicles need distance to reach MRF site. So average distance between containers. First, we'll see the distance between the containers. Container 1, container 2. Container 1 is there. This is container 1. Container 1. Container 2. So their average distance between two containers. So it is 0.16 kilometer. 0.16 kilometer. The distance between two containers is 0.16 kilometer. And constant for estimating driving time between container location for both haul and stationary container system are A is equal to 0.060 hours per trip. This is the constant for A and B. B is equal to 0.42 hours per kilometer. So A and B is the constant for estimating driving time between container location for both haul and stationary container system. A is equal to 0.060 and B is equal to 0.042 kilometer. 42 hours per kilometer. So these two has been given, and the average distance between two containers is 0.16 kilometer per hour. 0.16 kilometer. So this is the data for the location data. It is already given. So on the basis, because location, all data are same, only what we have to calculate, we have to do analysis of the container system, like which one will be more cost effective or which one will be means economical. That's why we are with the same data we are calculating for both of the one, like haul container system and stationary container system. So next we'll discuss about the NW. NW is equal to for haul container system is equal to weekly quantity of waste collected upon average container size into container utilization factor. So this is NW. NW is equal to weekly quantity of the waste collected, means VW. For is equal to VW, weekly quantity of waste collected, that is V and W. CF is the first is the average container size is C, and F is equal to container utilization factor, means the factor which will be given. So as we know, VW, V is weekly quantity of waste generated, waste collected. So VW is equal to 230, and average container size is equal to, means like C. Average container size is equal to C. So C is equal to 6 as it has been given in the data, and the container utilization factor, that is F, is equal to 0.067. This has been given. So three data has been given. So on the basis of, we can calculate haul container system NW. So is equal to 230, like weekly quantity of waste collected divided by 6 is the average container size, and the container utilization factor is it is fixed like 0.67. So is equal to 57 trips per week. So the data has been given like 57 trip they have to do to collect in a week. 57 trip this haul container system, 57 times they have to do the hauling of in a week. So total trip is the 57 number of trip, means in a week in this haul container system, vehicle has to do the operation in a 57 times. 57 times the vehicle has to do the operation, and it is per week. So the data, first of all, we have calculated the how much trip this in this hall container system is required for this much of waste. So for 230 of the waste, 230 is the weekly quantity of waste collected. 230 amount of waste, 230 meter cube of the waste is collected in a week, and the collection container utilization fact size, container size is 6 meter cube, and the utilization factor is 0.67. So for this much of waste, for a hauling purpose, for a hauling operation, 57 number of trips they have to be required in a week. So this has been given for this NW we have calculated like 57 trips they have required. Now comes to the next point, estimating the average pickup time for haul container system. Now we'll calculate the average estimate time, means for a 57 trips, 57 number of trip in a week, how much time they has been given for a single trip. So for this one, already the formula has been given, PHCS. PHCS I have already discussed in the last class. PHCS is the estimating the average pickup time for the haul container system. So for average pickup time, what we have to use, PC plus UC plus DBC. PC is equal to time required to pick up the loaded container per hour in a trip. UC is equal to time required to pick up empty container. Like PC is the time required to pick up the filled container, loaded container per hour in a trip. UC is equal to time required to pick up empty container, that is per hour in a trip. And DBC means what? DBC is represents time required to drive between container location, means this is the hauling time, that is DBC. DBC is the hauling time, like the total distance the vehicle is covering during the whole operation system. And PC is the time required to pick up loaded container. UC is equal to time required to pick up empty container per hour per trip. And DBC is the total time required to drive between the container location. So it is per hour in a trip. So it has been given like PC plus UC. So is equal to PC plus UC plus A plus BX. That has been constant. This A and BX is the constant because that has been already given. So let us assume that 0.33 time required for the pickup loaded container, and the same time required for the time pickup empty container also, 0.33 plus 0.060 that has been given as a constant, and a 0.042 that has been already given like 0.16. So if we'll calculate all those things, we'll find that 0.133 hours it required per trip. So it required in a single trip, how much time it required? 133 hours per trip. Okay. So in this way we have calculated the average pickup time. Average pickup time we have calculated. In the first part we calculated like how much trips it required. Next, average pickup time it will required. So average pickup time is 0.133 hours per trip is required, and PC is the pickup time required, as we have already discussed, like PC is total time required to pick up the loaded container. UC is time required to pick up the empty container, and DVC is total time required to drive between the container location. So this we have calculated like this, and by the given formula, PC plus UC plus DVC, and DVC is equal to A plus BX. DBC is equal to A plus BX. A plus BX has been calculated 0.6060 plus 0.042. So the total average pickup time is 0.133 hours per trip. And now comes to the another part of this problem statement. Next, we will calculate the estimate the time required per week as a function of the round trip haul system. Means this is the we have to calculate the different. Another part is like that the total time required in a week as a function of the round trip hauls, means as a function of the round trip haul, means both the trip of the haul. So as a function we have to calculate. So for this one, what we are using the formula like TW is equal to NW, means like trip, and PHCS plus S plus A plus BX, okay, divided by H in under bracket 1 minus W. So NW we have already calculated like 57, that is trip. This PHCS is we already calculated by 1.3133 plus 0.53 plus 22 plus 0.014x. So this has been given, and 8 is equal to total time, like 8 weeks. 8 is there, 1 minus 0.15, so is equal to 1.74 plus 0.12x d per week. So for this one, this has been given like 1.74 plus 0.14x d per week. So as a function of the round trip haul distance, it will estimate the total time required per week as a function of the round trip haul distance is this one. This has been given. So this equation will will use in the next part of this problem statement. So we already calculated the number of trip requires, average number of distance time, and estimate the time required per week as a function of the round trip haul distance. Now comes to the second part, different part of this uh, haul container system value. So if we'll calculate, so now let's discuss the another part of this numerical, this problem statement, determining the weekly operational cost as a function of the round trip haul distance. So as a, if we will calculate the week, we have to calculate the weekly operational cost. Weekly, how much cost is required as a function of the round trip haul distance. So operational cost is equal to operational cost per hour, means cost per hour into daily total hours of the operation and time required per week. So that is per hour time is the 1067 as it has been given in the problem statement, and daily total hour operation is 8 hours in a per day, and function time required per week is that has been already given 1.74 into 0.12 per kilometer into x days per week. So it has been given like for 14,582 into 1024 as a function of x rupees per week. So overhead cost will be as this has been already given for a week is 28,000. So operational cost plus overhead cost, then total cost as a function. If we'll see, this one is the total cost as a function. It is like 43,046 into 64 plus 32 is a function of x. So if we'll calculate the weekly operational cost as a function of round trip haul distance is this much of the as a function of round trip haul distance, this much is required. And operational cost we calculated with the formula operational cost per hour into daily total hour of operation, time required per week. So for all both of the operation, the time is 8 hours in a day, and this 1,000 rupees is for this all container system, and stationary mode is I think 1,200. So it is little bit high than this one. Okay, now comes to the other part of the other part of this numerical. So here we have to calculate like determining the number of containers empty per trip. So for this one, like we have to determine the number of containers that has been empty per trip. In a trip, how much container will be empty? So it has been collected CT. It has been represented by CT. So volume of collection vehicle into compaction ratio VR divided by CF, container volume into utilization factor. So 23 into 2 divided by 6 into 0.67 is equal to 11.44. So is equal to 11 container. 11 container is required number of container empty per week. So in per trip, in a trip they'll empty 11 containers. Now estimating the pickup time per container. So this one is about to we have to estimate the pickup time per container. So it has been represented PSCS is equal to CT UC. UC we have already know plus NP minus 1 and DBC. So is equal to CT UC plus NP minus 1 A plus BX is equal to 11 into plus 11 minus 1 into 0.60 plus 0.042 into 0.16. So is equal to 1.22 hours per trip. So CT plus UC and P minus 1. So and DBC, total DBC can be represented like this, A plus BX. So it has been already calculated like 11 container has been empty in a single haul trip. So 11 has been empty into 0.050 plus NP is like 11 containers. So and 11 minus this one, and this has been already given as a function of this total haul time. So 1.22 hours per trip. In if 11 container has been empty in a single trip, then it has been required 1 hour 22 minutes in a trip. So in a trip of 1 hour 22 minutes, 11 container has been empty in a single hauling system. So this is like a total time we have calculated will be spent while emptying a container in a trip. So in a trip, 11 container has been empty. 11 container empty. 11 container is empty in a trip, and the time required is 1.22 hours per trip. 1.22 1 hour 22 minutes in a single trip. To empty 11 containers, time required is 1 hour 22 minutes in a single trip. Now comes to the another part of the location, another part of this numerical. This is like determine the number of trip required per week. So per week how much trip is required. So per week it has been, the trip required is like weekly quantity of the waste collected. NW in haul container system is like NW is equal to VR upon CF. So CF is already given. So 230 divided by 23 into 2 is equal to 5 trips per week. So in a week, 5 trips is required. So first of all, VR is the weekly quantity of waste collected upon average container size, that is C, and F is a utilization factor of the waste, container utilization factor. So on the basis of if we'll calculate, we'll find that 5 trips in a week is required for haul container system, and estimate the time required per week like TW as a function of round trip haul distance. So this one will be as a function of haul trip with a round trip distance. So it will be calculated by the formula TW is equal to N into P SCS plus TW, and it is S plus A plus BX divided by H1 minus W. So if we'll put the formula, it will become like this. TW is equal to 5 into 1.22 plus 5.1.22 plus 0.14x. per week. So this will, as a function of the round trip haul system, this is the required for calculating time required per week. So TW is the time required per week into N into P. N we have already calculated, like N is the total number of trip required. P is equal to time required for empty container, So for 11, if for 5 empty container, the time required is 1 hour to 22 minutes. So like this we calculated this formula, like 5 into 0.1 plus point is a function of it, and then this is like, so we will get this as a function for the estimate the time required per week. Now comes to the another part. We will going to calculate now with the for the round trip haul system. For this one, like how much time is required. So determining the weekly operational cost as a function of round trip haul distance. So for a weekly operational cost as a function of round trip haul distance, so it can be calculated like this: operational cost per hour into daily total hour of operation upon and the time required per week. So 1400, as it has been already given, 1400 total amount is there, and the whole operation timing is 8 hours per day, 8 hours in a single day. And this is the this has been the function of the time required per week as a function. So 0.92 plus 0.1 kilometer per x. So and total amount in a week is required is like 10,473 plus 1100 rupees per week, and total overhead cost is 53,000. That has been given in a week. In a week, overhead cost is 53,000, which has been already given. So total cost is operational cost plus overhead cost, means the cost involved for the operation, whole operation, and the overhead cost per week. So this you can see that 10,473.28 plus 113.84x plus 53370. Total cost is 63,843 plus 113. So this will be the function of the total cost that has been given as the x. This should be like this. Now comes to the this type. This is the comparison of the system. So if we will compare on the basis of the cost we calculated. So for haul container system we calculated total cost is 43,000. And for this one stationary collection system we calculated is around 63,000 in a week. This is the haul container system total cost, total operational cost in a week, and this is the stationary collection system or total operational cost in a week, like this is 63,000. So if distance between the haul distance is 0 kilometer, so the this will be like same, because this has been calculated for the 0 kilometer. For 1 kilometer, if the distance should be the round trip haul distance is 1 kilometer, like the haul distance, like from the last pickup point to the station to the MRF location site. If it is a 1 kilometer distance, 1 kilometer distance, for 1 kilometer distance, this much of amount is required, either for stationary system and for haul container system. For 5 kilometer of distance, distance from MRF site, so this amount is required. Like this 10 kilometer distance from MRF site, this amount is required. So for up to 15 kilometer, this amount is required. 20 kilometer distance, this amount is required. 25 and 27, and maximum 27, up to 27 we have calculated. So for a week, if it is a 30 kilometer, around 26 kilometer, so the total operational cost will be 70,000, and for this one, it is 66,000. So if we'll go for this haul container system, stationary container system and haul container system, we can find that for a largest distance, for a more distance, this will be, its cost will be more, means haul container system cost will be more, and stationary container system cost will be less. So we cannot compare the efficiency of both the container system. But when we talk about cost effective of these two container system with the comparison, with a comparative study, so then we can say for a smaller distance, for up to 5 kilometer of distance, up to 5 to 10 kilometer of distance, haul container system will be effective. But if it will be more than 20 kilometer distance, then this stationary collection system should be effective. So if more distance, this is effective, and less distance, this is effective. Now comes to the next thing that has been given in a plot has been given. So with the plot, we have done this comparison of this haul container system and stationary container system. So for the stationary container system, it will be up to 22 kilometer. This their rate will be not much variation is there. But for this one, for this stationary hall container system, you can see that with distance rising, their amount is also rising. So for a more, if location is for a distance is more, like up to 25-kilometer distance, so this one is better. And if distance is less, up to 15-kilometer, this stays a hall container system will be best. So if you will find an cost effective method for this hauling of solid waste, then this one is good, like stationary container system is good. Stationary container system is cost effective for larger distance, for larger distance more than 25 kilometer. Now comes to the an alternate way, like alternately, if different method different if we'll see by different view, like determining the maximum round trip haul distance at which the cost of haul container system equals the cost of a stationary container system by equating the total cost of two system and solving for x. So total cost HCS is equal to total cost like TSCS. So 43,000, this one will be the function, and this one will be the function for hall, stationary, and this one will for hall container system. So if we'll calculate x, we'll find that 11.5 kilometer is the best one-way distance. If you are going for one-way distance, then up to 11.5 kilometer will be effective. So this is the this in this lecture I have discussed about the both of comparison method for both of the system, like which one is best, either hall container system or stationary collection system, amount and time required, and the cost. If on the basis of cost effectiveness we'll calculate, we'll find that which method will be best. So in this lecture I have discussed about the comparison study between both type of collection method, like hall container system and stationary collection system. So and we have solved one problem statement related with this collection system. So we get analysis like this. If you are going for the smaller area, like up to 10 kilometer, then this hall container system will be effective. But if you are selecting a path that is more than 20 kilometer, then this stationary collection system will be better for the collection of whole garbage and hauling to the MRF location site. So this was a problem statement that we have been calculated, we have been solved to know the actual analysis of this haul container system. So in the next class, I'll discuss about the characteristics of the solid waste at the municipal level. So this today I am concluding this lecture, and next class I'll discuss about the collection and not collection method, characteristics of the waste. So thank you for today's lecture. And one more thing, if you have any doubt regarding this lecture, if you have any query, so you will write in the comment box, or you can directly mail me on the given mail ID, that is Shikha, Shikha, Shikha.pandey@gmail.com. So please write to the mail ID if you have any query. And thank you for this lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.